curvature, Q has lesser curvature than P, and the straight line has zero curvature. And we observe that a circle has constant curvature at any point. So as we move, the curvature changes, but circle is only one such curve for which if you take curvature at any point, I have not told you yet how to find the curvature. I have not told you yet. We are going to learn how to find the curvature. We are going to learn that. Okay, but the value will be same. Okay. One more thing we observed that we derived one from this. This is the curvature d psi by ds. This is from geometry. This is the AB is that curve and P is the point. We have discussed all those things and we observe that curvature is the value of d psi ds. But again, finding curvature using this is different. So we are going to have a different formula. What is that formula? So we observe this diagram. At any point, two curves can have the same curvature. We have seen this yesterday only. Precisely, given any curve and we pick up any point, we can always find the circle having the same curvature. Right? There are infinite circles. Like I can form a circle with any curvature because I can expand and contract. So circle is a very special curve in case of curvature. We can form like given any value, given any value of curvature, we can find the circle. Can you see this is very obvious? Can you see? This is very obvious. Like corresponding to curvature 2, there is a circle having curvature 2. There is a circle corresponding to curvature 2.5. Like any number you pick up, you can always find a circle. It is just about expanding and contracting. Are you convinced? Like there exists at least one circle with the same curvature, with any
Yes,
given
sir.
curvature. That is always
Yes.
possible. So what we're doing is we are going to find this circle of curvature. How to form, we'll learn now. It will have a particular center and it will have the particular radius of curvature. So these two things we are going to find out: radius of curvature and center of curvature. Before that, the curvature is given by um, this formula. This is the formula. We have proved it. Yes, the proof is here. We don't need the proof though, but quickly we will see. This is the formula of curvature. Rho is equal to wait. Hmm. This is the curve. No. Wait. Radius is this. Oh yes. Uh, where is that line? Yes. Okay. Yes. The radius of curvature. So how to find curvature? Again, I'm saying we are going to find the center and the radius of that particular circle. Now, first thing, the radius of curvature, the reciprocal of the curvature of a curve at any point, provided this curvature is not zero, is called the radius of curvature. That's all. This is the value of the radius. Again, we have still not learned how to find curvature, but we have defined radius of curvature is the reciprocal of curvature. So rho is so curvature was d psi ds, rho will be ds d psi. So basically, when we are asked to find curvature, basically we find the radius and then we reciprocate it. This is how we find. This is the alternative definition. Hmm. Basic definition of curvature is this psi ds. Radius of curvature is reciprocal of this. That is ds d psi. But again, finding the value of rho. So rho is a standard notation. Rho stands for radius of curvature. Now this value we will derive as this. This is the value. Let me this. Rho is uh, look at the first one, not the second one. Just the first one. I don't know how to highlight this. Can you see this diagram? Like rho is equal to 1 plus dy dx whole square to the power 3 by 2 by double derivative. Wait, let me open a very clear. Can you see this diagram? The upper one, not the lower one. Rho is equal to 1 plus dy dx whole square, 1 plus dy dx square whole to the power 3 by 2 by double derivative of y. This is the radius of curvature if the equation of the curve is given as y is equal to fx form. If the equation of the curve is given in x equal to fy form, then this one, 1 plus dx dy whole square 3 by 2 by d2x dx dy. They are similar. This is same thing as we did in surface and volume of revolution. Remember, just swap x and y. So remember only one. Remember the upper one. This is the value of radius of curvature. Rho is equal to 1 plus dy dx whole square 3 by 2 by d2, so on. Now given any curve and any point, I can find the radius of curvature. So in order to find the curvature, now let us learn how to find the curvature. In order to find the curvature at a point, we basically find radius of curvature and then invert it. Got it? Is that
Yes.
okay? Right?
Yes,
This is how we find the curvature. ds disha, finding the value of curvature using disha ds is very difficult. So we go a different way. First we find radius of curvature, and radius of curvature is inverse of curvature. So invert it. Let us see some problem. So we have to remember this formula. This formula you have to remember. This one. 1 plus dy dx whole square to the power 3 by 2 by 2 by dx square. Okay. Oh God. Okay. Let us see a problem. Do we have a problem out here? No. Okay. Let's do one problem. Okay. Center of curvature I'm coming later on. This is the question. Question number 1. Find the radius of curvature of the parabola y is equal to 4s at its vertex. Hence, find the curvature at that point. So first we find the radius and then find the curvature at that particular point. You tell me what is the vertex of this parabola. Y is equal to 4s. What kind of parabola is this? Upward, rightward? What kind of parabola is this?
Rightward.
Rightward.
Rightwards. Open rightwards. And what is the vertex?
4.
No.
Sir, 2
A equals to 1.
What is the vertex? Vertex of the parabola. That is my question. What is the vertex? Which point is called the vertex of parabola? Yes. Conic sections.
Sir, the turning point.
Sir, 0, 0, 0, 0.
0, 0. The tip of the parabola, isn't it? The tip of the parabola, where the parabola is turning, going back. That is the vertex. Right? That is the vertex. A comma 0 is the focus, isn't it? So there are like three main, not three, 2 main terms. One is the focus, one is the directrix. The point where the parabola meets the axis is called the vertex. Chalo. So we have to find the radius of curvature of this parabola at the vertex. At every point, the curvature will be different, right? You know the shape of parabola, isn't it? Can you? Are you
Yes,
convinced?
sir. Yes,
At
sir.
every point,
Yes, sir.
the bending is different. So we have to find the radius of curvature at the tip, at the vertex. Hence, find the curvature. Chalo. How to do it? So keep in mind, don't look at the center of curvature. I have not told you it. Remember this one. Radius of curvature is given by 1 plus dy dx whole square to about 3 by 2 by double derivative. Let's do. So basically, we need these two things. We need these two quantities, dy dx as well as d2 by dx square at that point. At that point we need. So the vertex is origin. So let us find y1 and y2. Okay, y1 means dy dx. So differentiating with respect to x, y1 is this. So now see, observe alternate formula. What is that alternate? Okay. Now observe, this is y1. When you find like y1 is dy dx at the point 0, 0, this is undefined. Can you see? What does this mean?
Yes, sir.
Like we have to put the value of dy dx at that point. The value of d2 by dx square at that point which has been asked. Now if I want to find y1 at 0, 0, so it is getting 0. It's undefined. It is undefined. So we'll go the alternate form. Alternate form means we will see the curve not as y is equal to fx form, but x equal to fy form. Like this, the alternate form, this one. Got it? The other one, dx by dy. We can see the curve as y is equal to fx or x equal to fy. That is up to us. Okay? Got it? So we will
Yes,
not
sir.
find dy dx and d2 by dx square. Rather, we will find dx dy and double derivative of x with respect to y. So hence we go to the alternative formula to find the ds. This one. So x1 means dx dy. So let's find with respect to x1 at 0, 0 it is 0 and x2 it is half. Can you quickly check what is x1?
Yeah. 0.
Dx dy is y by 2. Can you check? Dx dy is y by 2. Can you verify? Dx dy is y by 2 and double
Yes,
derivative
sir.
of x is half.
Half.
So if you put these things, rho you get 2. So 2 is the
Yes,
radius
sir.
of curvature. And k, it is actually not k, it's a Greek letter kappa. It looks like k. You must have heard this term kappa. You have heard this
Yes,
term
sir.
physics, right?
Yes,
So
sir.
kappa. Kappa stands for curvature. Since the radius of curvature is 2, curvature is half. Finished. This is how we do. This is how we find radius of curvature and curvature. Again, I am repeating. Given any curve, you find the first and second derivative. Find these values of first and second derivative at the given point. The point will be given to you. Always. Always the curve and the point will be given to you. So find the value of the derivatives, first and second derivatives at the given point and put in the formula. Finished. That's all. Is that okay?
Yes, sir.
Chalo. Try to do this. Find the radius of curvature of the curve this at the point where the straight line y is equal to x cuts it. Can you tell me which point they're talking about? We have done a similar kind
Origin.
of
Origin.
No. This curve does not pass through origin, by the way. Read the question properly. At which point? The point where this curve meets the straight line y is equal to x. So which
Sir,
point
A
they're
by
talking
4.
A by 4.
A square by 4.
When I'm saying point, it has coordinates. Something,
No,
comma,
sir.
something.
Yes, sir, A
X
by
is
4,
a
comma
square.
A by.
Sir,
Hmm?
x is a square by 4, sir. And
Why?
y, saying, sir. So
It's
y is
wrong.
also same.
It is not a square by 4. It is wrong.
Sir, A by 4, comma A by 4.
A by 4, comma A by 4. Exactly.
Yes, sir.
A by 4, comma A by 4 is the point. If you put A by 4, you'll see it's getting root A. Is that okay? So basically, you have to find the curvature of this curve. Root x plus root y is equal to root A at the point A by 4, comma A by 4. I told you, the point will be always be given to you. They may not give you straightforward, but they may change the language of the question. So this is the point is A by 4, A by 4. Chalo. So what you do? Find dy dx and find d2 by dx square. Find the value of dy dx at A by 4, A by 4. Find the value of d2 by dx square at A by 4, A by 4. and put in this formula. Chalo, karo to. Do this and tell me how much you're getting. These are easy sums, very mechanical.
Sir, dy/dx is coming as -1 at 1
Finally, tell me the
4.
final answer. Tell me the final answer. Radius of curvature. So read the question very carefully. What they have asked. Have they asked radius of curvature or curvature? Whatever they ask, you always have to find the radius of curvature, because this is the only way out. If the question is radius of curvature, you get the answer directly. If the question is curvature, you first find the radius and then invert it. So tell me, what is the value of rho, radius of curvature? Yes, could you find?
Sir, the answer is a/4 into 2 to the power 3/2, like that.
Rho is 3/2.
No, a/√2.
Rho is a/√2. Check. Rho is a/√2. Correct. A/√2. This is the calculation. This is the entire calculation.
Yes.
So differentiate with respect to x. y1 is -1. Right?
Yes,
Yes,
sir.
sir.
Y1 at a/4 is -1, and y2 is 4/a. Is 4/a. Correct?
Yes, sir.
So when you put everything, you get a/√2. Done. Okay? Similarly, we have another now. So this is how we find radius of curvature and curvature. So remember one thing: the basic diagram. The curve is given, and we are trying to find the circle of curvature. For finding circle, we need two things: one radius, one center. Radius we have found already. This is how we find the radius. Next is center. What is the center? Chalo, let's go for that. This is the center actually. This center we're talking about. What is there is a again there is a proof why it is 1/r. There is a small proof out here. It is written why radius is inverse of curvature. The proof is here. Anyway, I'll put this proof in the main note. I'll put this. So we will see why it is the inverse. Okay, now coming to the center. This is the center. This. The center of curvature of the point xy is given by this x bar y bar, or sometimes we write xc yc. This x bar y bar is the formula is this x minus y1. This formula you have to remember: x minus y1 by y2 into 1 plus y1 square, and y plus 1 by y2 into 1 plus y1 square. This is the formula of the center of curvature, and you get questions like this too. Find the center of curvature, find the radius of curvature, or simply find the curvature. So again, this proof is also I have put in the main note. As of now, just see, we don't need the proofs anyway, but it is always good to know the proofs, why they are coming. So I have put the proof in the main note. Next day when I'll be sitting, that is tomorrow only, when I'll be sitting, I'll show you the proof, why it is coming. Also, I'll put this proof, why radius is inverse of curvature. This small proof, it's out here. We'll see it properly. Tomorrow we'll see when the main note comes. Okay. So as of now, remember this. And anyway, for examination, you have to remember this only. You don't have to know the proof, but the proof is very easy. It's one line proof. So, whenever you are learning something, you should know why it is happening rather than mugging it up. You should know why it is happening. It's very important. Otherwise, it makes no sense of learning. If I give you the formula, then you should immediately question, sir, how is this formula coming? So I put that in the note. Tomorrow only I'll show you. But as of now, let's proceed. X minus y1 by y2 by 1 plus y1 square. This. Chalo. Let's do an example. We'll do one solved example, and then I'll ask you to do one more example. So this is the question. Find the center of curvature of the curve this at the point. Okay. So again, as you see, this is the formula. The formula is given x minus y bar. X bar y bar is the center of curvature. So again, as you can see, you have to find y1, y2 only. Obviously at those 2 points. Let us find. So the curve is given. We find out y1 and y2. So the point is given to be 1, 1. So y1 at 1, 1 is minus 1. Y2 at 1, 1 is 4 by 3. When you put, the center of curvature is this. 5 by 2, 5 by 2. Done. Got it? Is that okay? Very mechanical. Very mechanical. You simply have to remember the formula. Is that okay?
Yes, sir.
Yes,
We
sir.
do. Chalo. Do one question now. Find the not find the evolute. Forget the evolute one. I'm coming to not evolute. What is this question? Okay, chalo. Let me. Right. Let me download one thing. I need to download one thing. I need to do some questions. Just give me 2 seconds, 2 minutes. Forget it. I don't have the question with me now. Okay, let's do this program only. What you do is, this question, find the first question which we did, y square is equal to 4x, we found out the radius of curvature. You tell me what is the center of curvature for this at the same point, vertex. Find out and tell me what is the center of curvature. Tell me the answer. It will be easy though. Diagrammatically also you can say this will be easy. Do one thing. Forget that. Do this question. That will be a bit difficult. You cannot find that way because you'll have this problem. Y1 wala problem. You'll have this problem. Do this question. Question number 2. Find the center of curvature for this at the point a comma a by 4 a by 4. Tell me. You keep doing. I'm just stopping the screen share for a while. Just keep doing it. Shoal করে তুমি underscore 34 কেন দাও? Shoal you are here?
Yes, sir.
হ্যাঁ, তুমি underscore 34 কেন লেখো? ওটা বড় বড় হয়ে যায়। underscore লিখবে না, 34 লিখবে, ঠিক আছে?
ওটা হ্যাঁ স্যার, মানে ওটা পড়ে গেছে।
হ্যাঁ, আগের দিনও পড়েছিল 34, জাস্ট 34 দেবে।
ওকে।
আর এখানে অবধি আছো?
হ্যাঁ স্যার আছি।
18 টা আগে লিখবে, রোল নাম্বার। রোজ আমি বলছি আগে রোল নাম্বার লিখবে, তারপর নামটা লিখবে, ঠিক আছে?
ওকে।
सेम गोज फॉर आदित्य बनर्जी, आदित्य, अमन, शुभजीत, मर्मिक, शाग्निक। मर्मिक तो रोल नंबर ही दो ना, मर्मिक हो यहाँ पर?
Yes, sir.
हाँ, ये रोल नंबर देना, तुम AIML लिखने की जरूरत नहीं है, बस रोल नंबर दे देना स्टार्टिंग में, ठीक है? अगले दिन से।
ओके सर।
सेम गोज फॉर आदित्य, अमन गुप्ता, शुभजीत एंड शाग्निक। Just put the roll number in the beginning. No AIML. AIML is not required. We know you are from AIML. ठीक है, but roll number is a must. And obdhi too. चलो।
Okay, sir.
Let me know when you are done. This is the formula of curvature.
Sir, 3/4, 3/4.
3/4, 3a by 4, 3a by 4.
Hmm.
Okay.
Yes, sir.
Others?
3/4, 3/4.
चलो ये होगा फिर. Anyway, you have these values. Y1 is -1, Y2 is 4. बस बैठा ही देना है इस फॉर्मूले में. -1/4.
हाँ sir.
बस इसी में बैठा देना है. क्या हो जाएगा? X के जगह a/4. Y1/Y2 will be what? -a/4. That is +a/4 into 1 plus 1,
1
2. So a/4
plus 2a/4.
plus a/4 तो 2a/4. So 3a/4 हो गया. x बार 3a/4 और उधर भी y की जगह a/4 और प्लस a/4. So a/4 plus 3a/4. तो 3a/4, 3a/4. ठीक है?
हाँ sir.
This is how we find center. चलो. So now we know the center is x bar comma y bar. The radius is rho. What is the equation of circle of curvature? What will be the equation? The center is x bar comma y bar. Radius is rho. So what is the equation of the circle of curvature?
It's y square plus ये होगा क्या?
हाँ क्या होता है सर्कल का? दो ही चीज चाहिए होता है सर्कल में, रेडियस और सेंटर. तो क्या बन गया सर्कल का इक्वेशन?
x minus x bar square plus
स्क्वायर प्लस y माइनस y बार का होल स्क्वायर इक्वल टू रो
equal
स्क्वायर.
to rho square. हाँ.
बस खत्म. But they never ask you the equation of the circle of, very rarely, 1 out of 100 question they sometimes ask you what is the equation of the circle of the of curvature. Generally they ask radius or curvature or the center. ठीक है, बस यही दो चाहते हैं. But remember the heading we are doing, the topic we are doing is evolute and involute. ये सब क्या पढ़ रहे हैं हम लोग, कर्वेचर एंड ऑल, क्योंकि अब हम लोग इवोल्यूट इन्वोल्यूट में जाएंगे इसके बाद. फ्रॉम दिस विल गेट इनटू इवोल्यूट. ठीक है, रिमेंबर द मेन टॉपिक इज, इफ यू लुक एट द सिलेबस स्टार्ट्स विद दिस इवोल्यूट एंड इन्वोल्यूट एंड वी आर डूइंग दैट टॉपिक ओनली. लेकिन उसको पढ़ने के लिए वी हैव टू लर्न ऑल दिस थिंग्स. ये कर्वेचर क्या होता है, रेडियस ऑफ कर्वेचर क्या होता है, सेंटर ऑफ कर्वेचर क्या होता है. नाउ विल गो टू इवोल्यूट. चलो, let's see what is evolute. Okay, let's see what is evolute. Before we do evolute, tell me, have you heard the term called locus? You must have heard.
Yes sir.
What is the meaning of locus?
Any moving point is called locus.
No.
Sir, path. The path.
Which path? Which path?
It's a trajectory.
Not necessarily trajectory. So,
Sir, any moving part जो cover करता है
so
path.
half answers we are giving, but all of you are partially correct. The path traced by a moving point, that is called the locus of that point. है ना? So whenever we have the term locus, immediately should strike our mind. We have something. We have a point which is moving. It has to be. Locus means it has to be a moving point. Now, when a point is moving, the path it is tracing, that path is called the locus of that point. ठीक है? याद आ गया?
हाँ सर. हाँ.
चलो अब now look at this diagram. जो डायग्राम दिखता है इसमें the curve तो ड्रॉ किया हुआ नहीं है. The curve is not drawn. बस टेंजेंट ड्रॉ किया हुआ है, which is making, oh नहीं, the curve दिया हुआ है. Okay, the curve is there. Okay, the curve is there. The curve is drawn. The point P is drawn, and we have seen at a particular point there will be a curvature corresponding, there will be radius of curvature and corresponding center भी होगा. एक circle भी होगा, center भी होगा. Now my first question. If I move the point P on the curve, listen to it carefully. If I move the point P on the curve, क्या रो और सेंटर सेम रहेंगे या चेंज हो जाएंगे? I repeat the question.
सेम रहेगा.
I am moving the point P on the curve. Change. स्टार्ट मतलब पी को हटा के कहीं और ले गए, वो रो और सेंटर वो दोनों के दोनों वैल्यू सेम रहेंगे या चेंज हो जाएंगे?
सर अगर कर्व पे ले जाएंगे तो सेम रहेगा सर।
सर सेम ही रहेगा।
सर वेरी करेगा।
ओके, सो टेल मी, सेम रहेगा वेरी करेगा? अगर वेरी कर रहा है क्यों करेगा? सेम रहेगा तो क्यों रहेगा? टेल मी, क्या लगता है?
सर पोजीशन चेंज हो गया तो ऑफ कोर्स कोऑर्डिनेट भी चेंज हो जाएगा।
पक्का चेंज होना है, सर्कल नहीं हुआ तो। अभी तक अब तक तो
হ্যাঁ
हम
স্যার
वही सीखा था।
স্যার
अगर
কার্ভে
point
চেঞ্জ
change
করলে
हो
ওই
गया तो उस
পয়েন্টটা দিয়ে
point
অন্য
तो bending
সার্কেল
पे-
হবে।
अगर उस पॉइंट अगर वो कर्व सर्कल नहीं है, इफ इट इज नॉट द सर्कल, द कर्व इज नॉट सर्कल, तो रो तो सेम रहेगा, लेकिन अगेन अगेन रिमेंबर, उसमें भी रो सेम रहेगा, दैट इज बिकॉज एट एनी पॉइंट द कर्वेचर इज सेम, बट सेंटर तो चेंज होता रहेगा ना, सेंटर को तो पक्का चेंज होना है।
यस सर।
और अगर कर्व इफ इट इज नॉट अ सर्कल, तब तो रो भी चेंज होगा, सेंटर ऑफ कर्वेचर भी चेंज होगा, होना ही है कि नहीं? आर यू अंडरस्टैंड? इट्स वेरी वेरी लॉजिकल। इफ आई एम मूविंग द पॉइंट P, दैट मीन्स इमीडिएटली एक दूसरे पॉइंट पे चले गए, वहां पर कर्वेचर कुछ और होगा, कर्वेचर कुछ और होगा मतलब क्या? रो कुछ और होगा, बिकॉज रो एंड कर्वेचर दे आर रेसिप्रोकल ऑफ ईच अदर, है कि नहीं? समझ में आ रहा है?
हाँ सर।
तो ऑब्वियसली अगर रो भी चेंज हो गया तो सेंटर ऑफ कर्वेचर भी चेंज हो गया। So can I say this? Can I have this statement that if I start moving the point P, the center of curvature also starts moving? Can I say this?
सर एक बार बोलिए तो।
If I start moving the point P on the curve, जो P पॉइंट है वो कर्व के ऊपर है, if I start moving it, तो center of curvature will also start moving. It also starts moving. वो भी चेंज होता रहेगा, है कि नहीं? थिंक।
हाँ सर होगा।
ऑब्वियसली होगा, है ना? ऑब्वियसली होगा, बिकॉज सेंटर ऑफ कर्वेचर उस पॉइंट पे डिपेंडेंट है। द सेंटर ऑफ कर्वेचर, द रेडियस ऑफ कर्वेचर, एवरीथिंग इज डिपेंडिंग ऑन द पॉइंट। हमने अभी देखा ना, जब वो वर्टेक्स के लिए एक आएगा, कुछ एक के लिए और आएगा, जैसे a/4 उस पॉइंट के लिए ही रेडियस ऑफ कर्वेचर a/4 है, a/√2 है, और सेंटर ऑफ कर्वेचर 3a/4 है। अब अगर मैं पॉइंट को a/4 a/4 से हटा दूं, क्या लगता है सेंटर ऑफ कर्वेचर
चेंज होगा?
3a/4 रहेगा?
नहीं सर चेंज होगा।
नहीं, चेंज हो जाएगा। That's what I'm saying. So it's very obvious. If I move the point P on the curve, the center of curvature will also move. अब वो जो सेंटर ऑफ कर्वेचर जो मूव करने लगा, सेंटर ऑफ कर्वेचर का जो पाथ है, एक पाथ बनेगा ना, जैसे मैं P पॉइंट बता रहा हूं, व्हाट इज द लोकस ऑफ द पॉइंट P? द कर्व इटसेल्फ, है कि नहीं?
हाँ।
P पॉइंट का लोकस क्या है? जो कर्व गिवन है। सेंटर ऑफ कर्वेचर का जो लोकस है, जो बनेगा, दैट विल बी कॉल्ड द इवोल्यूट। किसका इवोल्यूट? इस कर्व का इवोल्यूट, जो कर्व गिवन है। इवोल्यूट ऑफ अ कर्व हमेशा होता है। समझ में आया कॉन्सेप्ट? सो इफ आई हैव ए कर्व, सो बेसिकली व्हाट इज इवोल्यूट? अगर हमको पूछे फाइंड आउट द इवोल्यूट ऑफ ए कर्व, हमको क्या करना पड़ेगा? आई टेक द कर्व, आई टेक अ पॉइंट ऑन द कर्व, और उस पॉइंट के करस्पॉन्डिंग सेंटर ऑफ कर्वेचर निकालेंगे। Now if I keep moving the point P, the center of curvature also starts moving. The locus of the center of curvature, एक कर्व बनेगा, that curve will be called the evolute of this curve, of the given curve. समझ में आया?
Means sir, evolute will be every time circle.
No, not at all.
So center of curve का तो सर्कल ही होगा ना?
Center will move. The center will move, not necessarily circle में होगा।
सर पैराबोला का भी सेंटर ऑफ कर्वेचर होगा?
बिल्कुल होगा, हमेशा हो सेंटर ऑफ कर्वेचर, किसी भी कर्व का होता है सेंटर ऑफ कर्वेचर। उसको जब मूव करेंगे तो जो जो कर्व बनेगा वो होगा इवोल्यूट।
मतलब सर मूव कैसे करेंगे, मींस
चलो
सेंटर ऑफ
ओके
कर्वेचर तो एक
ओके
सर्कल का ही हो रहा है ना।
ओके ओके वेट 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 चलो लेट मी just give me 2 minutes, let me show you one thing. Okay, wait. So I'm stopping the screen share. Okay, so we have ठीक है, this is the curve, this is y is equal to fx given, ठीक है, this is the curve, okay.
हाँ सर।
अब इस पॉइंट पर दिस इज माय फर्स्ट पी, तो इस पॉइंट पर तो मान लो दिस इज द सर्कल, दिस इस पॉइंट पर दिस इज P1, इस पॉइंट पर रेडियस इज ρ1, ऑन सेंटर इज x1 बार y1 बार, मतलब ρ1 मान लो कुछ इतना है, दिस इज आवर ρ1 एंड दिस इज द सेंटर, ठीक है, इज इट ओके?
यस सर।
चलो अब मैं पॉइंट को यहां पर ले आया P2, इस पॉइंट में रेडियस ऑफ कर्वेचर ρ1 रहेगा या कुछ और हो सकता है?
कुछ और भी हो सकता है।
कुछ
और भी
और
हो सकता है। चलो मान लो ये बढ़ गया, मान लो ये हो गया दिस, और सेंटर ये अपना सेंटर है, दिस इज x2 बार y2 बार, और चेंज किया, मान लो ऐसा है, इससे छोटा, दिस इज ρ3 बार P3, ये रेडियस हो गया ρ3, ये सेंटर। तो अब जैसे ये P को चेंज कर रहा हूं, ये सेंटर का पाथ कैसा है देखो, तो कुछ ऐसा है ना, ये जा रहा है, ये जा रहा है, ये जा रहा है, ये जा रहा है, तो क्या है सर्कल बन रहा है, कोई जरूरी नहीं है, सेंटर मूव करेगा एट दिस पॉइंट, दिस इज द सर्कल ऑफ कन्वर्जेंस, इस पॉइंट के लिए ये सर्कल ऑफ कन्वर्जेंस है, अंडरस्टैंड द कॉन्सेप्ट, इस पॉइंट के लिए ये सर्कल ऑफ कन्वर्जेंस है, हर एक पॉइंट पे सर्कल्स ऑफ कन्वर्जेंस बन रहा है ऑब्वियसली, बट लुक एट द सेंटर, हाउ द सेंटर इज मूविंग, सेंटर का जो पाथ होगा दैट नीड नॉट बी अ सर्कल, आर यू
ओके
गेटिंग,
सर। यस
आर यू
सर।
गेटिंग? तो वो जो पाथ बनेगा दैट इज कॉल्ड द इवोल्यूट, किसका, इस कर्व का, द गिवन कर्व का इवोल्यूट है वो, दिस कर्व इज द इवोल्यूट ऑफ दिस, और ये जो पेरेंट कर्व है दिस कर्व इज कॉल्ड द इनवोल्यूट ऑफ दिस। सो इवोल्यूट इनवोल्यूट एक आपस का होता है, लाइक फादर एंड सन, so x is the father of y is the son of x, वैसे ही this is the evolute of this curve is the involute of this, the evolute, समझ में आया?
हाँ।
So basically I can say एकदम स्टार्टिंग में
सर
दिया है,
ये माने इनवॉल्यूट कर्व जो है उसका जो कर्वेचर का मतलब सेंटर होगा उससे मतलब नहीं है।
बिल्कुल है ना, so इनवोल्यूट जो ये तो मेन अपना इनवोल्यूट बन गया ना, तो इसके किसी भी पॉइंट पर एक सेंटर ऑफ कर्वेचर आया, उसी का तो मूवमेंट है इवोल्यूट, उसी का तो पाथ है।
नहीं नहीं सर, मैं बोल रहा वो वाला लाइट जैसे इनवॉल्यूट है उसका सेंटर ऑफ कर्वेचर तो कुछ और ही होगा ना, ऑफ कोर्स ये 3 पॉइंट तो कभी नहीं हो सकता।
किसके बात कर रहे हो, ये इवोल्यूट इसका?
नहीं नीचे वाला पेरेंट वाला।
ये हाँ हाँ, नहीं इसी पे जो पॉइंट है उसी पे, तो उसी पॉइंट पे तो सेंटर ऑफ कर्वेचर निकाला, आर यू गेटिंग? जो कर्व दिया हुआ था उसी के पॉइंट पे तो हमने सेंटर ऑफ कर्वेचर, हर एक पॉइंट के अगेंस्ट पे हमने सेंटर ऑफ कर्वेचर निकाला, उसी का तो चाहिए।
अगर सर सर्कल होता तो
सर्कल होता तो चलो मान लो ये सर्कल है, अब सर्कल थोड़ा स्पेशल है, कोई भी पॉइंट ले लो, रो तो सेम रहेगा, है ना, है कि नहीं?
हाँ सर।
रो
Yes, sir.
सेम
सर
रहेगा।
डिसजॉइंट सर्कल बनेगा।
नहीं, वेट, अब देखो इसका मजा क्या है,
तो
इसका जो
statement
रेडियस है वही तो सेंट, मतलब जो सर्कल खुद है, इसका जो कर्वेचर है वो तो रेडियस खुद ही है ना, यही तो रो है। इसका जो रेडियस है वही तो उसका रेडियस ऑफ कर्वेचर बन गया, क्योंकि वो खुद बन गया, है कि नहीं? समझो बात को,
Yes, sir.
हाँ हाँ।
right? The radius itself is the radius of curvature because the curve itself is a circle, correct?
हाँ
Yes or no?
Yes, sir.
यस
So
सर
the
यस।
center of curvature is nothing but the center of circle, है कि नहीं?
Hmm.
If I keep moving p, रो सेम ही रहेगा, सेंटर भी सेम ही रहेगा, can you see?
Yes, sir.
So in this particular case, this is the only special case जहां पर मैं p को तो मूव कर रहा हूं लेकिन सेंटर ऑफ कर्वेचर नहीं हिल रहा है, वो एक ही जगह पे स्टैग्नेंट हो गया है। सो बेसिकली p को अगर मैं मूव करूं, द सेंटर इज नो मोर अ मूविंग पॉइंट, इट्स अ स्टैग्नेंट पॉइंट, उसका कोई लोकस होगा ही नहीं। आर यू गेटिंग?
तो सर सर्कल का इवोल्यूट नहीं होगा कुछ।
सर्कल
सर
एग्जैक्ट,
लोकस
सर्कल
एक्चुअल
का
में तो एक्स और वाई होगा ना जो बार है।
एक सेकंड बिफोर दैट ही सेड अ वेरी नाइस लाइन, सर्कल का कोई इवोल्यूट होगा ही नहीं। गुड, अब बताओ, यस टेल मी योर क्वेश्चन, यस टेल मी।
सर सर्कल का तो लोकस है ना वो सेंट्रल पॉइंट।
अच्छा चलो, लोकस किसे कहते हैं हम, किसे लोकस कहते हैं हम?
बट वो मूव
सर
नहीं कर रहा है।
पॉइंट, एक पॉइंट जो मूव करेगा उसके पाथ को हम लोकस कहेंगे, ठीक है? इसमें
हाँ
क्या था, एक कर्व दिया हुआ था, हर एक पॉइंट मैंने सेंटर ऑफ कर्वेचर निकाला, तो हम जैसे पॉइंट को चेंज कर रहे हैं, ये सेंटर ऑफ कर्वेचर भी मूव कर रहा है, मूव करना
हाँ
पड़ेगा तभी लोकस का सवाल उठता है। तो सेंटर ऑफ कर्वेचर जैसे जैसे मूव कर रहे हैं, सेंटर ऑफ कर्वेचर का जो पाथ है वो बन गया इवोल्यूट। इसमें सेंटर
हाँ।
ऑफ कर्वेचर मूव ही नहीं कर रहा है, स्टैग्नेंट हो गया है,
ओके सर अंडरस्टूड अंडरस्टूड।
तो लोकस का बनेगा ही नहीं, लोकस मूव ही नहीं कर रहा है पॉइंट। ये पॉइंट तो मूव कर रहा है लेकिन सेंटर ऑफ कर्वेचर को मूव होना है, अपना इवोल्यूट क्या है, सेंटर ऑफ कर्वेचर का लोकस है। यहाँ पर सेंटर ऑफ कर्वेचर दिख रहा है मुझे, तो मूव कर रहा है, यहाँ पर मूव ही नहीं कर रहा है। हेंस जरूरी नहीं है कि हर कर्व का इवोल्यूट हो। एग्जांपल ये सर्कल, सर्कल का कोई इवोल्यूट होता ही नहीं है, ठीक है?
हाँ सर।
चलो अब अपने को सिलेबस में पढ़ना क्या है, रनिंग आउट ऑफ टाइम, आई विल फिनिश विद दिस वन सिंगल। एक कर्व दे देगा, यू विल हैव टू फाइंड द इवोल्यूट, इवोल्यूट निकालना है, बस यही अपने का काम है। बस ये सब अपना टॉपिक खत्म, और कुछ नहीं है, तो ये मॉड्यूल खत्म हो जाएगा। कर्व दे देगा और बताएगा कि फाइंड आउट द इवोल्यूट, वही हम अगले क्लास में सीखेंगे एंड विल फिनिश दिस मॉड्यूल। दैट इज टुमारो विल लर्न हाउ टू फाइंड द इवोल्यूट ऑफ ए कर्व एंड देन फिनिश दिस मॉड्यूल, ठीक है?
ठीक है सर।
टॉपिक इज स्क्रीन, ओके। चलो फिर वी मीट टुमारो, ओके?
ओके।
चलो
Thank you, sir.
Thank you, sir.
Okay.
थैंक यू
Thank you,
सर।
sir.